Hello everyone and welcome back to my channel. This is the A+ Tutor. Today we're going over dividing complex numbers. Complex numbers are the set of all numbers in the form a plus bi, such that a is a real number and bi is an imaginary number. Real numbers are basically any number you can think of that's positive, negative, a whole number, or a decimal. Whereas imaginary numbers are numbers that have I in it, where I is the square root of -1 and I squared is equal to -1. For example, say we have the square root of -81. Well, this is equal to the square root of -1 times 81. We can break this apart into the square root of -1 times the square root of 81. We just said the square root of -1 is equal to I. And the square root of 81 is equal to 9, so this is equal to 9i. Or we have 5i squared. Well, that squared can go to both the 5 and the I, so we would have 5 squared times I squared, which would be equal to 25i squared. I squared is equal to -1, so this is 25 times -1, or -25. To divide complex numbers, we're going to use complex conjugates. So if we're dividing two complex numbers, for example, a plus bi over c plus di, to find our complex conjugate, we will take our denominator and change the sign of that imaginary number. So in this case, our complex conjugate would be c minus di. So whenever we have fractions, we never want a square root in the denominator. As soon as we have an I in our denominator, we have the square root of -1 in our denominator. So the way that we get rid of this radical in the bottom of our fraction is we multiply by the complex conjugate. After we find our complex conjugate, we're going to multiply our numerator and our denominator by that complex conjugate. When we multiply our original complex numbers by the complex conjugate on top and bottom, c minus di over c minus di is equal to 1. So we're not changing the value of our expression. But this problem becomes a plus bi times c minus di over c plus di times c minus di. From here, we want to FOIL our numerator and denominator. So our numerator, of course, will be FOILed and we're going to have a long expression. But let's take a look at what happens to our denominator. When we FOIL, this becomes c squared minus c di plus c di minus d squared I squared. Negative c di and positive c di will cancel. And I squared is equal to -1, which means negative d squared times -1 becomes positive d squared. So our denominator actually becomes c squared plus d squared, and now we've gotten rid of our square root in the denominator of our fraction, and we can simplify this. So let's take a look at an example. Say we have 4 plus I over 2 minus 5i. The way we find our complex conjugate is we look at our denominator and we change the sign. So 2 minus 5i is going to become 2 plus 5i, and we'll multiply our numerator and our denominator by that complex conjugate. So we'd have 4 plus I over 2 minus 5i times 2 plus 5i over 2 plus 5i. This is going to be equal to 4 plus I times 2 plus 5i all over 2 minus 5i times 2 plus 5i. We're going to FOIL our numerator and denominator. FOIL just stands for first, outside, inside, last. So we're going to do that on top and on bottom. In our numerator, we'll have 4 times 2 is 8, 4 times 5i is 20i, I times 2 is 2i, and I times 5i is 5i squared. All over, in our denominator, 2 times 2 is 4, 2 times 5i is 10i, negative 5i times 2 is negative 10i, and negative 5i times 5i is negative 25i squared. We want to combine our like terms. So in our numerator, 20i and 2i are like terms. In our denominator, positive 10i and negative 10i are like terms. Also, we want to simplify anywhere we have an I squared. So in our numerator, 5i squared will become 5 times negative 1, or negative 5. And negative 25i squared will become negative 25 times negative 1, or positive 25. So our expression becomes, when we start to simplify, 20i plus 2i is 22i, and 5 times negative 1 is negative 5, all over. In our denominator, we have 4. 10i and negative 10i will become 0, and negative 25 times negative 1 is positive 25. Now we'll combine our like terms again. 8 and negative 5 are like terms in our numerator, and in our denominator, 4 and 25 are like terms. So our final answer is 3 plus 22i over 29. Now let's look at some examples of dividing complex numbers. For our first example, we have negative 1 plus 5i over negative 8 minus 7i. Our complex conjugate, remember we're looking at our denominator, so the complex conjugate for our imaginary number will be negative 8 plus 7i. We're just changing that sign in between our real number and our imaginary number. So we're going to multiply our numerator and our denominator by that complex conjugate. When we multiply, we're going to FOIL, so our numerator is going to be negative 1 plus 5i times negative 8 plus 7i over negative 8 minus 7i times negative 8 plus 7i. We'll FOIL both our numerator and our denominator. So for our numerator, we get negative 1 times negative 8 is positive 8. Negative 1 times 7i is negative 7i. 5i times negative 8 is negative 40i. And 5i times 7i is positive 35i squared. All over, negative 8 times negative 8 is positive 64. Negative 8 times 7i is negative 56i. Negative 7i times negative 8 is positive 56i. And negative 7i times positive 7i is negative 49i squared. We'll combine our like terms. So in our numerator, our like terms are negative 7i and negative 40i. In our denominator, our like terms are negative 56i and positive 56i. And then we'll rewrite our I squared as negative 1. So in our numerator, 35i squared becomes 35 times negative 1, and negative 49i squared becomes negative 49 times negative 1. So this is equal to 8. Negative 7i minus 40i is negative 47i minus 35, all over 64. Negative 56i plus 56i is 0 plus 49. Combining our like terms again, now we have 8 and negative 35, 64 and 49 in our denominator. So our final answer is negative 27 minus 47i over 113. Next we have negative 7 plus 6i over 10 plus 5i. Our complex conjugate is going to be 10 minus 5i. Since we have 10 plus 5i in our denominator, we're just going to change that sign, and the conjugate is 10 minus 5i. So we'll multiply our numerator and our denominator by that complex conjugate. So this becomes negative 7 plus 6i times 10 minus 5i in our numerator, and 10 plus 5i times 10 minus 5i in our denominator. We're going to FOIL both our numerator and denominator. So that's just first, outside, inside, last, on the top and bottom of this fraction. So this becomes negative 7 times 10 is negative 70. Negative 7 times negative 5i is positive 35i. 6i times 10 is positive 60i. And 6i times negative 5i is negative 30i squared. In our denominator, we have 10 times 10 is 100. 10 times negative 5i is negative 50i. 5i times 10 is positive 50i. And 5i times negative 5i is negative 25i squared. We'll combine our like terms. So in our numerator, 35i and 60i are like terms. In our denominator, negative 50i and 50i are like terms. And we'll rewrite our I squared. So negative 30i squared becomes negative 30 times negative 1. And negative 25i squared becomes negative 25 times negative 1. So our expression becomes negative 70. 35i plus 60i is 95i plus 30 over 100. Negative 50i plus 50i is 0 plus 25. We'll combine our like terms again. So now our like terms are negative 70 and 30 in our numerator and 125 in our denominator. So this becomes negative 40 plus 95i over 125. Now, although it looks like we're done because we don't have any i's in our denominator, we do need to take one more step here, and we need to factor out our greatest common factor from both our numerator and our denominator. In this case, our GCF is 5. So when we factor out a 5 from our numerator, we get 5 times negative 8 plus 19i, and in our denominator, we get 5 times 25. So those 5's will cancel out. And now we are left with our true final answer, which is negative 8 plus 19i over 25. Next we have negative 2 minus 9i over negative 2 plus 7i. Here our complex conjugate is negative 2 minus 7i. So we'll multiply that to the top and bottom of our fraction. So this becomes negative 2 minus 9i times negative 2 minus 7i over negative 2 plus 7i times negative 2 minus 7i. We'll FOIL our numerator and our denominator. So that gives us negative 2 times negative 2 is positive 4. Negative 2 times negative 7i is positive 14i. Negative 9i times negative 2 is positive 18i. And negative 9i times negative 7i is positive 63i squared. In our denominator, we get negative 2 times negative 2 is positive 4. Negative 2 times negative 7i is positive 14i. Positive 7i times negative 2 is negative 14i. And positive 7i times negative 7i is negative 49i squared. In our numerator, our like terms are 14i and 18i. And in our denominator, our like terms are 14i and negative 14i. And our I squared becomes negative 1. So in our numerator, we have 63 times negative 1. And in our denominator, we have negative 49 times negative 1. So this expression becomes 14i plus 18i is 32i minus 63 all over 14i minus 14i is 0 plus 49. Now 4 and negative 63 are like terms, and 4 and 49 are like terms. So our answer becomes negative 59 plus 32i all over 53. And that's our final answer. Next we have 4 plus I over 8 plus 9i. Our complex conjugate will be 8 minus 9i. So we'll multiply our complex conjugate to our numerator and our denominator. And our expression becomes 4 plus I times 8 minus 9i over 8 plus 9i times 8 minus 9i. We'll FOIL our numerator and our denominator. So we get 4 times 8 is 32. 4 times negative 9i is negative 36i. I times 8 is positive 8i. And I times negative 9i is negative 9i squared. All over 8 times 8 is 64. 8 times negative 9i is negative 72i. 9i times 8 is positive 72i. And 9i times negative 9i is negative 81i squared. Our like terms in our numerator are negative 36i and 8i, and in our denominator, negative 72i and 72i. And I squared becomes negative 1, so we have negative 9 times negative 1 in our numerator, and negative 81 times negative 1 in our denominator. So this expression becomes 32, negative 36i plus 8 is negative 28i, plus 9, all over 64. Negative 72i plus 72i is 0, plus 81. Now 32 and 9 are like terms, and 64 and 81 are like terms. So this expression becomes 41 minus 28i over 145, and that's our final answer. Next we have negative 3 minus 2i over negative 10 minus 3i. Our complex conjugate is negative 10 plus 3i. So we'll multiply that to our numerator and our denominator. So our expression becomes negative 3 minus 2i times negative 10 plus 3i over negative 10 minus 3i times negative 10 plus 3i. We'll FOIL our numerator and our denominator. Negative 3 times negative 10 is positive 30. Negative 3 times 3i is negative 9i. Negative 2i times negative 10 is positive 20i. And negative 2i times positive 3i is negative 6i squared. In our denominator, negative 10 times negative 10 is positive 100. Negative 10 times 3i is negative 30i. Negative 3i times negative 10 is positive 30i. And negative 3i times positive 3i is negative 9i squared. Negative 9i and 20i are like terms in our numerator, and negative 30i and 30i are like terms in our denominator. And negative 6i squared becomes negative 6 times negative 1, and negative 9i squared becomes negative 9 times negative 1. So our expression becomes 30 plus 11i plus 6 over 100 plus 9. In our numerator, 30 and 6 are like terms. In our denominator, 109 are like terms. So our final answer is 36 plus 11i over 109. And now for our last example. We have 3 plus 9i over negative 6 minus 6i. Our complex conjugate is negative 6 plus 6i. We'll multiply that to our numerator and denominator, and our expression becomes 3 plus 9i times negative 6 plus 6i over negative 6 minus 6i times negative 6 plus 6i. We'll FOIL our numerator and our denominator. So we get 3 times negative 6 is negative 18. 3 times 6i is 18i. 9i times negative 6 is negative 54i. 9i times 6i is positive 54i squared. All over, negative 6 times negative 6 is positive 36. Negative 6 times 6i is negative 36i. Negative 6i times negative 6 is positive 36i. And negative 6i times 6i is negative 36i squared. In our numerator, our like terms are 18i and negative 54i. In our denominator, our like terms are negative 36i and 36i. And in our numerator, 54i squared becomes 54 times negative 1. In our denominator, negative 36i squared becomes negative 36 times negative 1. So our expression becomes negative 18 minus 36i minus 54 over 36 plus 36. In our numerator, negative 18 and negative 54 are like terms. In our denominator, 36 and 36 are like terms. So we get negative 72 minus 36i over 72. Now, we do have a greatest common factor in all of these numbers. If we factor out a 36, we're left with negative 2 minus I over 36 times 2. That will cancel. And our final answer is negative 2 minus I over 2. Thank you so much for watching. I hope you enjoyed and I hope you learned something. If you have any questions or would like to see any topics, please comment down below. Make sure you're subscribed to my channel so you never miss another video. See you next time.